All right, we'll jump into this question then. Excuse me. We'll jump into this question while we let a couple of remaining people join. So I just thought like maybe we could all go around and say, what sport do you least understand? And for me, it's this game of cricket. I am an American, and so I have no international exposure to any games like cricket, but I know that it's pretty popular elsewhere. But I did, when I was in high school, my physics teacher he was a pretty relaxed guy, and he was from Pakistan. He was a pretty laid back teacher, and instead of a formal semester exam, he took the day and just explained cricket to us. But that was many years ago. I don't remember how it is. But anyway, cricket is a sport that I do not understand. And if you want to answer this question, either as you don't understand the rules or you don't understand how anybody could possibly watch the sport, both of those are valid responses. So who has one that they want to offer?
Oh, I can.
Okay.
I don't like your football because it's not football, you know. So it's not football. I only believe in soccer, and yes, exactly. So yeah, yes, all American sports are not really yeah.
Right. I had a funny feeling that American football would come up.
Yeah, exactly.
All right. Anybody else?
I have to agree with cricket too. I used to have some people that I knew overseas from Australia, New Zealand. They tried explaining it to me, and I just, it's really hard to understand. I know it's super popular, but I tried to understand it, and the rules were tried to explain to me.
Yeah.
I couldn't get it.
Yeah, takes a lifetime of learning, I guess. All right, anybody else?
I guess I don't understand curling, ice curling.
Right. I know that. There's probably like a whole bunch of sports that come up during the Olympics that nobody understands except for during that.
Yeah, but it's physics. You know, it's because I'm in Canada, so I can't say something bad about curling, but it's about physics, and it's so nice to have men sweeping a lot.
Very good.
I understand the base premise of it and how it's scored, but then like when they start talking about strategy, I don't get that. Like where they get the blocker, and then that just goes over my head.
Yeah, I think it's funny that there's like curling experts that do nothing for 4 years until the Olympics pulls them back out of anonymity and puts them onto the broadcast. Hey, Chenli.
Hello, it's finally working.
Yeah, it's working. We were just talking about sports that we least understand. I don't know if you had one.
I'll say golf.
Yeah, golf.
Yeah. I don't know how to enjoy like yeah. It seems fun, but yeah, it's always interesting to me.
Very nice. Yeah, me too. I don't get golf. All right, very good. Well, we are at our time then, and we'll let Bruno or whoever else join if they need to. This is what we're going to cover today. Mostly we're going to just do chapter 7. So we got through a number of sections in chapter 7 last week, but there was one part that we didn't get to. So instead of actually making it through the whole rest of chapter 7, what we'll really do is just review last week's topics and then do that one last section that we didn't get to in depth, and then we'll probably be done a little bit early today. So all right, so I will put up the housekeeping reminders just so that you can keep them in front of you. If we need to slow down at all, feel free. There's always plenty of resources to learn the theory behind the things that are going on here, so you can do those, or you can look those things up, and then do the exercises and plan on teaching one of the lessons at some point. It'll be very helpful as we go through and try to grasp these concepts. All right, cool. So the next several slides are really just going to be recaps of what we talked about last week. So if you recall that when we looked at the diamonds data set that gets loaded with the tidyverse, and we had all of these different categories and in the data set. There were about 10 different categories, and some of them included things about different diamonds that we're all sort of familiar with: the carat, the cut, the color, and the clarity. And then there were these that had to do with the dimensions. There were a total of 5,000, almost 54,000 records. But you can see the first few of them when you do this command, head diamonds. Okay, cool. All right, and so then we went into visualizing the distribution. The first approach that we took was to count the number of diamonds that fell into each of the cut variables: fair, good, very good, premium, and ideal. And this was the code for that. So we went straight into the ggplot command, where we used the dataset diamonds. We added on the geom bar. And as you'll remember, there's a lot of different geoms that you can use. In this case, we felt like the bar was probably the best. And then you map the different variables from the data set using this AES. You can use mapping equals AES and then the parentheses. And in this case, we wanted to make the x-axis was equal to the cut. And then the other thing that we wanted to make sure to point out is that the geom bar, whenever it automatically uses count for the y-axis. That's the default for geom bar. But if we ever wanted to use something different, we could specify that. If we wanted to use like a sum or something like that. I don't recall that we actually did that last week, but that it's important to know what the defaults are, what the default y-axis is for each of the different geoms that we use. All right. After we graphed using the cut variable, then we went on and did the same thing with the carat variable. Now, the important thing to remember about the cut versus the carat variable was that the cut was a categorical variable, meaning that there were only a few possible choices in that category. What we have here with the carat variable is that it is a continuous variable, meaning that we're actually using a number, and the values of the carat could be any of a nearly infinite number of values. So you can have integer values, 1, 2, 3, 4, 5. You can have decimals. You can have any number of decimals that measure that, because they are a continuous, because carat was a continuous variable. Right? So when we do that, the thing that we have to remember is that to make a continuous variable into categories that you can count, you have to split the whole range of those of that continuous variable into buckets that you can deal with, and you do that with this bin width argument here. So we said that the bin width would be 0.5 carats. Okay, and as you look, you can see that each of these bars spans about 0.5, half of a width of carats of values there. Naturally, if you increase the number of, or if you decrease the bin width, then you'll increase the number of bars, and vice versa, which was the next thing that we did. I didn't capture that here, but you'll recall that we changed I think that's on the next one actually. Yeah, we changed the bin width from 0.5 to 0.1, which increased the number of bars and made them skinnier. Yeah. We also made a point to call out this filtering option. Okay, you'll recall that we had this big long tail down here that looks like there's hardly any values that actually fall into this upper area of carats, and we wanted to filter those out because there were so few of them. So we added in this filter step, and we were able to do this using the pipe. And you'll recall how the pipe works. You start out with the data set, and then you move on to the filter, and we filtered that to be the carat is less than 3. And then the pipe again to move on to another step of actually graphing it out in GGPLOT, and then we filled out the rest of the visualization code there. All right. And we talked about this one already. You remember that we went into visualizing these distributions in other ways. where we wanted to add in, we had already graphed the distribution using the histogram values based off of the caret size, and then we wanted to add in this color based in the fill size. So we add, or based on the cut variable. So we added in this other argument, fill equals cut, and then that produced this right here. We also noted then that at this point, using a geom of histogram probably isn't the best option, because it doesn't let us do the kinds of comparisons that we want to. And so we changed that over to frequency poly or freq poly here. And then it changed it up, and so that everything starts at 0 and the lines all are comparative. Yeah. All right, good. Okay, I think that catches us up on what we covered last week. Does anybody have any questions? Has anybody had a chance to use some of this, practice it, done any of the exercises, learned something new about all of this that you didn't know before? Let me give you a second to weigh in. Anybody?
I liked how you talked about that geom histogram, using that kind of fill aesthetic, and talking about the differences where when you're using geom histogram with the fill, it's really hard to make those comparisons. But then when you use the frequency poly, you can make those comparisons a lot easier.
Yeah.
That was kind of nice. And then I think I mentioned this last week too, with the like the count cut width, to kind of see the bins. I think that was helpful to kind of see how the bins are actually calculated, and to kind of see how it splits that continuous variable.
Yeah, and we'll look at a couple of slides where the count width comes in. And I didn't fully understand it last week when we talked about it, but then playing around with it a little bit more this week, it came in really useful. So so thanks for bringing that up next week. We'll see it here in just a couple of slides too. So. Anybody else? Any other thoughts on any of this? Okay. Yeah, and Colin, you mentioned about the geom histogram and finding the right visualization for what you're trying to present. And at the very end today, we're going to look at the visualization, or the GGPLOT cheat sheet. And that can give us also some ideas about the best ways to present different kinds of data that we have too. So we'll just move on from there. All right, very good. So then that got us through most of this 7.3 section. The one last thing that we hadn't covered was how to zoom in on different sections of the graph, right? So for the next couple of slides, we're going to talk about zooming in on the long tail of diamonds. Okay, so we have to step back a couple of steps and remove the filter so that we see all the values of caret, and we're using the bin width of 0.5. Okay, so what we have over here, this is like the very first time that we visualized using the carets variable, because it's not filtered. There's no colors and so on, right? So we've got this long tail where we know that there's values. We know there's values down here because the axis extends all the way out to 4 or 5, but there doesn't seem to be anything significant there. So we want to zoom in just into this section and see what there is. So that's the goal here. So before we can really do that super effectively, we have to notice something. So you notice under this geom histogram, notice that the first bar actually spans into the negatives. Okay, so everybody see that, where this is 0 on the x-axis, but the bar itself seems to encapsulate some values just negative of that. And that doesn't make sense, because no diamonds are going to have a negative caret, right? Everybody follow that? Okay. So what's actually happening here is that the default behavior of geom histogram is to make the center, or make the width, or the bar, kind of center around these values. So the bar here is centered on 0. It's centered on 0.5 right here. The next one is centered on 1. Does everybody see how that works? So the intervals that we've specified, this 0.5 interval, the bars center on that value. Here's 1.5, here's 2, and you can see the bar for 2 actually extends a little bit before 2 and a little bit after 2. So that, it throws things off a little bit because we're trying to say like carrots of a certain value. Well, we don't want to capture, for instance, like a negative one. You can see this a little bit as well over here if you use the cut width, the count and the cut width. So if you use diamonds and then you pipe, the next thing you do is you count the cut width, and cut width means you to take all of the values of the caret. We know that the whole range of those goes all the way from essentially 0 all the way up to about 5, and you cut those into equal widths of 0.5 carats. You can see down here how it does that. It takes one value that's negative 0.25 to 0.25. The next bucket is 0.25 to 0.75, 0.75 to 1.25. Everybody sees how that goes, right? And then it buckets the number of diamonds that fall into that caret width. Okay? So we've specified cut width of 0.5. We get those different buckets, and it tells us the number of diamonds that falls into that. But if we wanted to, but what we really want to do is, if we're going to zoom in on this long tail and we only want diamonds that are larger than 3 carats, do you see how that might make it a little bit hard? Because there's no bin that's exactly starts at 3 carats. Okay, all we have here is, the closest we have is 2.75 to 3.25. So if we were to put in a filter that says, show me everything greater than 3 carats, you'll basically be splitting these 32 diamonds. Some will be greater than 3, some will be less than 3, and it won't correspond with the visualization. Won't be what you expect. Okay, I hope that makes sense. I was trying to explain that as well I could. Everybody kind of get it? If not, stop me and we'll go back and try to explain it a different way. Okay? So the first step, if we want to focus in on this long tail and we only want to look at carats that are greater than 3, the first thing we need to do is stop the visualization from spanning each of these tick marks. Okay, we've got to line them all up with the tick marks. Okay, so you do that using this argument, boundary equals 0. Okay, so by adding in boundary equals 0, it's going to line up the bar with the 0. So now the first bar spans from 0 to 0.5 carats. The second one is 0.5 to 1 carat, and so on. Okay, and you can see it a little bit more clearly over here on the right hand side when you look at the actual numbers of diamonds, that the buckets now line up more to what you might think of when you look at, you know, 0.5, a bucket of 0.5 carats. So you have 0 to 0.5, 0.5 to 1, 1 to 1.5, and so on. Okay, so it's that boundary equals 0 is what helps that to line up. And now what can happen is we can actually say greater than 3 carats, and you can see that the bar it stops. Like there's a bar that actually stops at 3. It goes from 2.5 up to 3. And then there are still values out here, but they're so small that we can't see them, which is the whole point of this exercise. We want to zoom in onto this section here. Yeah. All right. So this helps us more intuitively say, filter carats greater than 3, and we can, and it at least for me, it tends to make a little more sense in my mind. Okay, and we can actually see over here on this side how many carats we're talking about, or sorry, how many diamonds we're talking about. we see that this interval is the one that starts at 3. This one happens to go to 3.5, and then the last one is over here and ends at 5.5. But we're talking about these diamonds right here, 23, 4, 4, and 1. Okay. So if we filter, then, or if we include this boundary, you can, yeah. So this is what we're talking about, right? So there's 32 diamonds that are larger than 3.0 carats, okay? But they're invisible on the graph. Okay. All right, good so far. So then the last step, after you've lined up the boundaries a little bit better, then you'll want to implement this code right here, xlim and ylim. Okay. So if we wanted to zoom in down here to everything greater, all the diamonds greater than 3 carats, then we would want to limit the x-axis to just values between 3 and maybe 6. Okay, so that's why we have xlim 3, 6. Means limit the x-axis to just those values, 3, 6. And then ylim from 0 to 50. Okay, and 50 is just an arbitrary number. You can see that these the y-axis starts at 5, or it starts at 0, and then 5,000, 10,000, 15,000. So naturally, anything down here in this tail is probably going to be an extremely low number. Okay, maybe 30, 50, 100, something like that. So by using ylim of 0 to 50, it limits the y-axis to those numbers, 0 to 50, and we get a much better view of what is actually down there in that long tail that you can't see. Okay. So if we make one last comparison, what we have here on this interval number 7 between 3 and 3.5, we would expect to see 23 diamonds. And you can see over here that that's exactly where it comes in, right? Between 3 carats and 3.5 carats, we have 23 diamonds, okay? And then from 3.5 to 4 carats, we have 4 diamonds, which would be right here. Here's the 10, so that's right at 4. Same with the next interval of 4 to 4.5, also 4 diamonds. And then the very last one from 5 to 5.5 diamonds, there's just 1. 5 to 5.5 carats, there's just 1 diamond, and that's captured here. Okay. So the main learning on this topic here is the use of this xlim of this xlim to limit what the x-axis goes to, and then ylim, which limits what the y-axis goes to. Equally, you could, if you wanted to just focus in on the very top of this other bar, this tall one, you don't have to start at 0. You could start at 15 or whatever, 20,000, and go to 22,000, and it would just zoom in on just that part. Okay. Good. Something to play around with, something to work with. Okay, so hopefully this exposes you to this idea of boundaries, to line up the bars the right way, and then also cut width to see how cut width works. There's a couple of other cut alternatives too. Cut n and cut interval, I think, or something like that. So you can look in the help under cut width, and it'll give you the different alternatives there to see. Okay. Any questions or any thoughts or input anybody has on these? No? All right. Okay. Then the last thing that I wanted to look at today is the GGPLOT cheat sheet. Okay, so you can go, let's see if this works. If you go up to, are you able to see my screen, the browser? Okay. All right, so if you can just Google for GGPLOT cheat sheet, and it'll bring up this. So we'll just walk through this really quickly. Okay. So you can see how it takes on the format the same format as most of the cheat sheets. And in this particular case, you get some information about the basics. And we've talked about this before, this idea of starting out with some data and then adding on a geome, then adding on a coordinate system. We haven't talked too much about the coordinate systems, but it'll come. And then that results in a plot. Talks a little bit about aesthetics and mappings. Okay. You can see some full code here about all the different layers that go into creating a plot. Yeah. So then there's a large section over here talking about geomes. And this is what I was talking about, where it can give you some direction on which might be a good geome to choose based off of the different kinds of data that you have. So if you have one continuous variable, then you might look at an area plot, a density plot, a frequency poly, or a histogram. Yeah, and then it lines out, gives you some information about how to create that. Okay, if you have two variables, maybe one's continuous. Two continuous variables. You have a number of different options here as well. So we have looked at Geom Smooth before in some of the early days. You can do text plots that way. Bivariate distributions. I think there's there are some exercises around these bivariate distributions coming up in this chapter, which we'll probably get to next week. And then geome lines and so on. Okay. So if you haven't had a chance to look at that yet, go ahead and pull it down and go over it and print it out and keep it close by. At some point, we'll talk about box plots, bar plots. You can see how they're all created. There's also a section here about maps. Gratefully, they included as a standard example the map of Texas. I had nothing to do with that, but it warms my heart. So, and then there's a little bit more about 3 variables and so on. Anyway, it's a good resource to get some experience and some exposure to different kinds of geomes. Okay. Then as we move down here to the second page of it, some other things that we've talked about even just briefly. One of these is the stats. So when we talked about the box plot defaults, the bar plot, we talked about the bar plot defaults to counting values. That's the stat. The default stat is to count. So if you ever want to change that, then you would be changing the stat. Okay. So you can change it to some of these. I'm trying to find a good example here. Some of these like value, you can see different outliers and anyway, you get the idea. So you can look through this and you can see what the different stats might be. Scales. I think scales will come in a little bit more in the future about how to plot those. And then coordinate systems we haven't talked about either, but you can plot on a polar coordinate system rather than just the regular XY Cartesian system. And then faceting, I think we may have talked about in the very beginning about being able to make different graphs based off of variables. So you could do a separate graph for each of the different cut values, a graph for fair, a graph for good cut, a graph for whatever they were, ideal, and so on. That's faceting. And then some other things about just I think they call them themes. So labels and legends and colors and different things like that. So make sure that you take a look at this one, at this cheat sheet. Here's what we were talking about just a minute ago with zooming, being able to use these XLim and YLim requirements, arguments to limit down what you're, where you want to zoom in. Yeah. A little bit more about shape scales too. Anyway, So that's that. Again, I would say go take a look at that, download it and print it out. And then as you go through your work and your development and you start to get some ideas about how exactly to visualize some of these data sets, this will give you some ideas and give you a roadmap on how to do it. So,
What exactly is stats doing?
what does stats do?
Yeah.
Yeah. Let me see if I can think of a good way to do it. I'm gonna do this on the fly. So let's see if this actually works. So if I come over here to R, let me find a good example here. Let's see if this does it. Let me go a little earlier. Okay, here we go. Okay, so if we do diamonds, count, cut, width, I remember how does cut width work? Oh yeah, caret. Okay, let's look at it this way. Yeah. All right. So here we go. And under you can see this code right here. ggplot diamonds plus geom bar aesthetic is cut. Yeah. So what that does is it takes all of the different cut values, and if we wanted to look at the cut values, there's these 5. Every diamond will fall into one of these 5. When the default stat for bar is count, which means that under fair, it counts the number of diamonds that are fair. Let me see if I can actually redo this now that I'm thinking about it again. Diamonds, count, cut. Just do it. Okay. So you can see the number of fair diamonds is 1610. The number of good diamonds is 4906. Very good is 12,000. And you can see those numbers represented here, right? What if instead of counting the number of diamonds here, we wanted to add up the total carats under fair, the total carats under good, and the total carats under very good, okay? So instead of counting just the number of records that fall under here, we're actually going to use this other category, this other variable of carat, and we want to sum the total number of carats for each of these categories, okay? So then, I think this is going to fail. So then we would add in here stat equals identity. Let's see what happens there. Yep, fail. Then width equals 0.5. Not bar. So outside the aesthetic. All right. I'm getting there, Monson. All right. The
Is
only
it geom bar?
sorry.
Instead of histogram, it's not bar.
Well, no, I changed it. We had to change it because the bar,
Okay.
geom bar, that one really only works with categorical variables like we had a second ago. So we can do that. GGPLOT diamonds plus geom bar. Yes, x equals cut. We can do a bar chart because because we have categorical variables down here. But because caret is actually a continuous variable, the histogram works better. Okay. So the thing is that we're still just counting records. Okay. And so what we had, I'm going to have to just do it here. GGPLOT. No. Diamonds. Garrett. Get it right. Okay. So, so to try to answer your question, Mansa, what we had was we have this histogram, but what it's doing right now is just counting. So it has no concept of how many carets are involved. It has no concept of anything other than just the fact that there are 785 records where the caret value falls between this range. And it has 29,000 where the caret value falls between this range. So these are just counting of records. And that's because the default stat for a histogram is count. Okay. Anyway, I don't know why I did that. But if we wanted to change it to where we were actually adding up the number of carets, then we could change this to identity. If I'm not mistaken. Somewhere, somehow, this works. I'll make this work. I came up with this at one point a while ago. I don't remember how I did it now. And I'm just getting a bunch of errors.
I got the concept.
Yeah. Let me look at how to if I can remember how to do it. But the idea is that when we had it a second ago with the regular, when we had it like this without a specified stat, it was just counting the number of records. But if we wanted to add up the number of carets, something other than just counting records, then we would specify a stat. And there would be a particular stat that says like sum the carets, something like that. That's not what it is, but it's a word here that tells you how to make those bars. Instead of counting records, it would add up carets. Okay. I hope that helps, but let me give it another try. I'll give it another try next week, and we'll make it clear. Okay. Clearer.
But you know, if I may, it's just that because when you don't use it a lot, it's quite confusing. You know, the ggplot, every time I forget. So usually, to remember, I go to Tidy Tuesday Twitter, I find something I like, and then after I go to the code and I copy what I need, because you don't need to reinvent everything all the time. And if you don't use it every day, you are likely to forget.
Right. Yeah, exactly. Absolutely. And that's the case. I mean, it's just like anything else, practice, right? So But yeah,
There
I'm sure there's more to explore on stats too than just those two things, but I'll look into it. Go ahead.
Yeah, so I have to find it, but there was a blog post. I can't remember who wrote it, but they did an excellent job of explaining how like all the stats work. And the whole premise of it was don't be afraid of the GGPLOT stats, because I'll be honest, I myself need to review the how the stats actually work. But I'm gonna see if I can dig up that blog post, because it when I first read it, I was like, this makes, it does a really good job of explaining that it's not as scary as it looks, because sometimes it's like, wow, there's a lot of options that you can do in it. So I'll see if I can find that and put that in Slack.
Okay, yeah, that'll be great. And then we'll touch on it again next week for sure after we get some examples to actually work, head off these errors that keep popping up. So. Okay, what else? Anything else from the group? All right. The only last couple of things that we had, just again, all the different resources to get help. I should add on to here Colin's blog posts. So there's always plenty of resources out there to find help and to get the answers that you need. And also, Sandra is just Google and copy from other people. That's certainly the way a lot of code gets written, I know. So. Then next week we will continue in chapter 7. So there's a few sections in chapter 7. So we've made it through one or maybe two of them. So we'll try to close this out as soon as possible. But just going back to what you mentioned before, it's practice. So take some time to work on the examples, explore your own questions as they come up, and you're through your coding, research, look things up, understand it, try projects at work or at school that you can implement this kind of stuff. I've had a couple of occasions to do it recently where I skipped the SQL solution and tried to do it all using the tidyverse, and luckily it came out. I did get an output. I now have to go back and validate that the output is real, which I'm going to do through SQL. But after a little while, one tool will hopefully supersede the other. But if you have some success stories like that, feel free to share them as well over the coming weeks. So. Cool. Is anybody up for picking up a lesson at some point? I don't mind finishing out chapter 7, but if anybody wants to take, I think chapter 8 is really short, or pick up chapter 9 maybe. Consider it. We can talk about it next week. I can
take, well, unless anybody really wants to jump in, I could take 8's really short, and then 8's really short, 9's just an introduction, and then there's 10.
Oh, yeah.
I think those ones are pretty short. I mean, I could do something for those. If anybody else wants to jump in, you're more than willing to take the spot, but I can do those as well.
Okay.
8, 9, 10.
I'll finish out 7 next week, but give it some thought if you guys want to jump in on any of these or collaborate on them. Somebody does one half, somebody does another.
Yeah, I mean, if anybody has a strong feeling of taking those, more than happy to let somebody take it. But Ryan, you've been doing a lot of work, so if you need a break, just let us know.
And Ryan, can you explain us how you make up your PowerPoint? Are you using Markdown? How do you make your PowerPoint?
I copy the one from last week.
Okay.
So I'll just show you over here. So
But do you use R to do it? Do you use Markdown? Or it just okay? It was just because I was curious to know that. Okay.
Yeah, no, it's just PowerPoint. It's just a PowerPoint one. So I happened across this view here, and that's the one that I took. So no, it's just in PowerPoint. I think Colin did one through R a couple weeks ago. So I haven't gotten that far yet, but I know R does have the capability to do it. So that'll be something to learn for sure in the future.
Yeah, it's you can do it. It takes quite a bit more time.
Okay.
When I first did it, I was like, whoa, this is a lot more time than I thought it was going to take. It's very rewarding, but Yeah, it takes a lot. It takes a little bit more time. I like the point and click. I might go back to that for 8, 9, 10.
Okay, no, it's good information to know that it's taking time because we are looking for something efficient. So if we have PowerPoint and if it's quicker, let us use PowerPoint. But I was just curious to know about it. Yeah.
Yeah, very good.
You can do some really cool things with it. The one thing that's just the hardest is like if you keep getting errors, like because what you have to do is you have to get R to process the whole thing. And then if you just keep getting errors, and you don't see something visually, it's very discouraging. And then you just want to kind of drop kick your computer. So, but I say take on the challenge. It's worth it.
Yeah, because I just began blogging, and with R, it's very, very easy.
Say that again.
I just began blogging. So in R, it's very, very easy to get right away something. Yes, it's impressive.
Nice. Okay. Well, you have to share your blog with us.
No, anyway, it is written in French.
Well, it's probably a good time for everybody to learn French. As long, right alongside R, right?
Yeah.
Very good. All right. Well, thank you, everybody. That concludes what I had prepared for this week, and then so for next week we'll cover a couple of the questions that came up just now. We'll continue on with chapter 7. We will try to assign out any future teaching opportunities that anybody wants, and we will read Sandra's blog. So I think all of those would be good. All right, I'll let you guys have your night back. Thanks again for everybody's participation, and we'll see you next week.
Thank you. Thank you all. Thanks, Ryan.
All right, bye-bye.